Welcome to Continental Hydraulics Introduction to Monitored Valve Products. Today we will try to cover who and what are the driving forces for these types of products, why these types of products are required, what products are available and how do they function, who should we present these types of products to. Why a spool monitored valve? This topic starts off being complex, and the more you study it, the more complex it seems to become. In reality, it's all about assessing, documenting, mitigating, and testing solutions that will eliminate or reduce the potential of harm. It is really just common sense. Machine designers and rebuilders are required by both regulations and a moral responsibility to ensure that the products they produce have been designed to limit the potential operational hazards and are as safe as possible. The most commonly referenced regulations is the Machinery Directive 2006-42-EC. Here in North America, our governing body, OSHA, has also adopted and applies these directives. These regulations are based on the standards as referenced in the ISO 13849 and the EN 692 documents. The Machinery Directive allows builders to freely offer their products to the global market that are recognized and are ensured to a high level of protection of both health and safety. The risk analysis process is based on the ANSI B11 standard flowchart. Step 1 in performing a risk analysis is to set limits and the scope of what is to be reviewed. Identify the hazards, then look at design options that can be changed. An example would be to look at a process line not as a whole, but break it into manageable sections. In this case, we'll break a process line into three main sections: an in-feed section, work section, and out-feed section. Then we will do the risk analysis on those individual sections. Once each of these areas has gone through this process, now the overall line can safely be controlled based on what each section reports conditions as. Example, if the in-feed section needs to shut down, the work and outfeed system may still operate. However, if the outfeed has an issue, the overall controls will or may shut down the other areas of operation depending on the state of what those machines are at. During the risk assessment process, a series of questions and answers will drive a designer to a PL or performance level of safety value. The questions that will be asked as we go through this process: what is the potential severity of the injury that could occur? Slight injury or serious injury? Second set of questions: how frequently will this potential happen? Seldom or frequent? Third, what is the possibility of avoiding or limiting harm? Possible or scarcely possible? The end result will determine a performance level that will need to be implemented for this function. Based on the results of this first pass, the designer may make design changes to the physical machine and then look at this process once again. The best choice in safety is to, if at all possible, design out the hazard. This slide has a lot of information and it'll take too long to get into all the details of each category requirement. For the purpose of this introduction, I will try to highlight the main differences and the basic terminology. Category B and Category 1 are items that we do on a daily basis. The components selected must be suitable for the application, correctly specified voltage, current, environmental condition, sizing the component correctly for the flow and pressure being used, and also ensure that we use well-tried industrial components and circuit principles. That must be part of the design. As fluid power suppliers and circuit designers, we deal with these two categories B and 1 on a daily basis. As an example, we all know not to specify an open-centered valve for an application that needs to hold the load in a fixed position when shut down. Category 2 and higher, they build upon this basic foundation of Category B and Category 1. Category 2 requires the addition of a monitored signal to validate that the function actually took place as directed of a single component. Category 3 shall be designed so that no single fault in any of these parts does not lead to the loss of a safety function. To meet this requirement for Category 3, redundancy is needed. With redundant systems, one channel or one valve can fail without losing the ability to stop the machinery because of the redundant valve circuit. Example, if one valve or monitored switch in a dual monitoring kit fails, the PLC can still shut down the second valve that will block the supply and bleed down the output as designed. In a Category 3, the restart function can reset if all monitored signals are corrected. The system should not permit itself to be reset if the monitoring system is not working. Diagnostics coverage can be low, medium, or high. Category 4. The difference between Category 3 and Category 4 is a higher diagnostics coverage average and a requirement for all the mean time to failure dangerous ratings of each channel to be high only. The biggest change from a Category 3 is that multiple failures will not lead to the loss of the complete safety function, and it will not allow the reset function regardless if all the monitored signals show correct. Reset must be performed manually or an act of will by the operator manually verifying all the safety is being met. How do these standards compare? As seen in the previous slide, we mostly talked about category levels, but as you notice on the chart, various PL ratings were also noted. This slide also adds the additional classification terminology called SIL, or Safety Integrity Level. This chart helps represent how these various rating systems compare one to each other. Once a category, a PL rating, or a SIL level of protection has been assigned to the process, the safety practitioner has to verify that the individual components, sensors, logic solvers, any type of final elements, valves, they are all working together to comply with the constraints of the required assigned level of protection. Also on this screen, you'll see some notes here regarding the mean time to failure values. Continental Hydraulics monitored valves will meet the requirements and fall into the high index value. If you need a copy of these mean time to failure data sheets, they are available. Please send a request in. We'll send them right out to you. Typical safety loop components. The number one thing in safety is the training that a company provides their employees on the safe and proper use of any equipment. All these components shown here, various switches, lockout, tagout, dual monitoring valve, pressure plates, light curtains, two-hand tie-downs, mechanical guarding, mechanical stops, they are only part of the safety training and control and monitoring validation system. I have a light curtain or I have a pressure plate circuit. I don't need a monitored valve. If you have a light curtain or a pressure plate, yes, you should have a monitored valve. The safety process needs to go all the way through the process. think deeper. Light curtains or a safety mat and monitor valves, they are only subsystems within the safety loop. They're just one link in the chain. If the critical function has a hydraulic valve in control, how do you know that it has indeed functioned correctly and went to the safe position? Where is the cross-checking logic? When correctly implemented into a high diagnostics coverage control circuit, these system components can meet Category 4 PL Level E or SIL 3 rating for equipment. The most commonly asked question is, what is the category your valves are rated to? Which actually is a good question, because they are asking what the valve is rated to. An individual component can only be rated to these standards as a component, as they are not the full safety control system. As per the ISO ratings, a standard valve, when designed correctly, will meet and support Category B and Category 1. Monitored valves will meet and support Category 2, validation signals. Dual monitoring kits will meet and support up to a Category 3. Category 3 was redundancy. Remember, we only sell components that are part of the safety circuit and not the safety controller or control architecture circuit being used. So, what is available? Monitored valves are available in direct operated DO3 and DO5 mounting sizes, and also available in the pilot operated DO5H all the way up to the D10 mounting sizes. Coils are only available with DC voltages. We have DIN or Deutsch connections. If you notice in the pictures here, we utilize a covered manual override to prevent actuation manually causing an unintended consequence. Again, think the process through. Make sure that nothing can happen if it's not meant to happen. What is a spool monitored valve? A monitored valve uses a switch that is mechanically attached to the sliding spool. Valves are available with 1 or 2 position monitoring switches. The basic function of the switch or switches used is to sense the neutral or powered down spool position. If the spool is moved out of the neutral or safe position, the switch senses the movement, and it can also indicate into which direction has it moved. The corresponding signals from the switch outputs are used by the safety control system to validate or to verify the request has taken place. The switches being utilized are the M12 4-pin connector with a PNP type switch. All of the data shown here is also in our catalogs. If you want to dig into it a little bit deeper, please download our catalogs off our website. We utilize several types of switches depending on if they are for a single solenoid valve or a dual solenoid valve. The most commonly used switch in the dual monitor in the dual solenoid valves is the RO. When in the neutral position, both outputs will show high. When one solenoid is actuated and moves the spool, one of those two signals will then drop low. This change in output status is used by the control architecture doing 2 important things. 1, alerts the system that the valve is no longer in the neutral position, and 2, based on which output has changed state, the direction that the valve is operating in. The M-type switches are commonly used on a single solenoid valve. Like the above, as the spool leaves or enters the neutral position, the switch will change state. The normally open and or the normally closed switch signals can be used by the control system. What is the safe condition? Is it critical to know if you are in a powered down condition or an actuated condition, or both? The best practice in using a monitored switch signal is to select a switch that will change state when it leaves or as it re-enters the safe or powered down state. The most commonly used and preferred would be the MB type switch, RO, or MO type switch. As seen in the actuation charts for these switch functions, options will change state when the spool is no longer in the home or safe condition. Dual monitoring kits meet and support a Category 3 redundancy requirement. The main hydraulic redundant function is to block flow and pressure and to relieve any downstream energy in a very simple, clean package. The package consists of a custom circuit design manifold and 2 monitored valves. The DO3 direct operated packages are used in applications for flows up to 15 gallons a minute and 5,000 psi. They are designed correctly. We use a series parallel type circuit. The series circuit, you must actuate both valves to allow pressure and flow to reach the outlet port. So as we're looking at the schematic, on the inlet, you must energize the very first valve in order to allow flow and pressure to continue on downstream to the second valve. When that valve energizes, the switch changes state. In order to get flow to the outlet, the second valve must be energized. The signal will change state. Now flow and pressure can continue on to the outlet port off to your system. The parallel circuit, if either valve is shut off, the outlet port is connected directly back to tank, draining the outlet port back to no pressure, no flow. So regardless of which valve gets shut off, the end result is the outlet is connected back to tank. That's the parallel part of the circuit. In these valves, we also utilize a true 3-way valve spool design. This means that it is a fully balanced operation, resulting in higher flow rates and safer operation. Other circuits that I've seen utilize a 4-way spool design, which is an unbalanced design. The flow forces will act upon the spool. Typically, these types of products are derated in flow and or pressure capabilities. So rather than being able to operate at 15 gallons a minute, they may be limited to 8 to 10 gallons a minute, and pressures may have been reduced as well. Because of the Bernoulli flow forces, the difference between a 3-way and a 4-way is you do have the unbalanced flow condition, which means the flow forces will and can act on the spool, holding it in a shifted position or shifting it back when not desired. We also use a ductile iron custom electroless nickel plated manifold, which is excellent for a washdown type environment. It's fully rated to 5,000 psi. Ductile is also compatible with all the fluids, including water glycols. For operations where you need a higher IP rating, like in a washdown type environment, you will need to select the W7 option for the corrosion resistance and utilize the Deutsch coil connections. The DO5 direct operated package is used for flows and pressures up to 30 gallons a minute, 4,600 psi. Just like in the DO3 package, they are designed correctly. We have the series parallel circuit, true 3-way spool design, the ductile plated manifolds with IP ratings as well. The DO8 pilot-operated packages, they're used for applications for flows up to 80 gallons a minute and 5,000 psi. The pilot-operated dual monitoring versions are standard with external pilot and external drains. For added safety, additional valving and switches can be incorporated into the pilot supply circuit, again making it much more safe and controllable. If you don't have a pilot flow or pressure, you cannot shift the valves, which means they are in the safe or powered down condition. Minimum pilot pressure is 200 psi and can go as high as 3,000 psi. The overall function, like the direct operated kit, uses the series parallel circuit and again a ductile custom manifold electronickeless plated. Again, we said safety needs to go all the way through. This guy weighs in at about 250 pounds. So as you're looking at the photo, you will also see lifting eyes. We would rather have you use the correct equipment for lifting this rather than trying to muscle it around. Again, safety needs to go all the way through the designs. When you receive a dual monitoring kit, you'll also receive a document to help you validate that the product is functioning correctly as designed. What you're seeing here is just part of the document that you will receive. It's a simple checklist that helps you validate and verify all the signals and functions are working correctly. As part of setting up the control loop to work this package, as well as any other component for that matter, the controls needs a reference time to expect to see a change in the signal state. Here you'll see that we do list the action fault monitoring times. When I energize a valve, what duration of time should the controller be looking for a change in state when it's turned on or whether it's turned off? These response times are listed here. There are two very important times that must be noted. Besides the valve performance response time, we also need to know the hydraulic system response time. The overall system response time is very key. System response time refers to the amount of time that it will take when a valve is shut down to the time that the outlet flow and pressure have dropped to a safe or zero output. In this example, this time will be used by designers to determine the distance that mechanical guarding will need to be positioned away from the function to ensure we are kept out of harm's way. Sistema software utility provides developers and testers of safety-related machine controls with a comprehensive support in evaluating the safety in context of the ISO 13849 document. This tool enables you to model the structure of the safety-related control components and with automated calculation of the attained performance level. Relevant parameters such as risk parameters, performance levels, measure against common cause failures, or multi-channel systems, the average component quality or mean time to failure values, and the average test quality, diagnostics coverage average, of the components and the blocks are entered in a step-by-step input diagnostics. Each parameter change is reflected immediately on the user's interface with the impact upon the entire system. The final results can be printed out in a summary document. This is a free software that you can download. Please go to www.dguv.de/webcode/E3483. There are many circuit designs that can meet PL ratings required. As you're looking at this, here's another example of a commonly used dual type circuit. The inlet flow and pressure must first go through the single solenoid monitored valve before the downstream dual solenoid directional control valve with monitoring. This circuit meets the requirements of this application for the performance level requirements. So there are a lot of different types of circuits that are out there. As time goes on, we will post more and more of these types of circuits to help you in your system design. A little bit about applied products. This power unit met category 3 ratings. As you can see right in the middle, yes, it did have a dual monitored valve package. That was the outlet going to the machine. All your filters have switches. There's pressure transducers. A lot of data acquisition type stuff was on this type of power unit. Along with the safety controller used and the safety circuit architecture used, the overall machine was approved for a Category 4 Performance Level E safety level, which is as good as it can get. So who should we introduce these types of products to? As salespeople, we do have our job cut out for us, and it's not always an easy task. These are two key target audiences that we need to talk to. One is the plant safety coordinator. Many companies continue to evaluate the long-term viability of their safety systems and current equipment. Some are considering upgrades, and others may say, if it isn't broke, don't fix it. The former can put companies into unnecessary risk for their employees and the future of their company. Failing to plan is planning to fail. Ben Franklin. Machine control engineers are key target audience for us. But besides the control engineers, who are typically brought into the machine design very late, you must also work with the machine design engineers on the front end. In many companies, these two groups may not work in tandem, but in series, where by the time the control person gets involved, they need to work around both the mechanical and expected budgets. Don't wait until your customers have an accident. Be proactive. With that, I would like to say thank you for listening in. I hope you found this introduction to monitored products helpful, and hopefully it clears up a few things for you. Please give us a call if you have any questions or concerns. We'll be glad to work with you on helping you design any type of control systems. If you need more data, please let us know. Again, thank you for your time.